Imagine, if you will, a time almost unimaginable, a universe in its infancy, barely a whisper of what it would become. The grand tapestry of stars and galaxies still largely unspun. For most of its existence, the cosmos was a dark, featureless expanse. But even then, in that deep cosmic night, a few beacons began to blaze forth. And among them, one, in particular, stands as a testament to the universe's capacity for the truly extraordinary. We are going to journey back, not just millions, but billions of years. We're going to peer into a cosmic nursery to witness something so colossal, so ancient, that it challenges our very understanding of how the universe built its first giants. It's a story written in light, a story from the dawn of time itself, carried across unimaginable distances to reach us today. The light we see from this particular object has traveled for an astonishing 13.03 billion years to reach our telescopes. Think about that for a moment. When that light began its journey, the universe itself was less than 5% of its current age. Just a tiny fraction of its unfolding story had been told. And yet, there it was, already a titan. Astronomers, with their penchant for the functional over the poetic, have given it the rather unexciting designation J0313-1806. But despite its bland name, this quasar, this radiant heart of an early galaxy, is an absolute astronomical Hall of Famer. Its sheer scale and profound antiquity place it in a league of its own, a truly mind-bending glimpse into the early cosmos. What makes J0313-16 such a marvel? It's the engine at its core, a supermassive black hole. And even at this incredibly early epoch, this cosmic baby picture, this black hole already commanded a staggering 1.6 billion times the mass of our own sun. Try to wrap your mind around that number. 1,600,000,000 suns compressed into a space far smaller than our solar system. It's an absolutely insane quantity of matter, a gravitational behemoth born almost at the beginning of time. And it's this immense power that allows quasars to do what they do best, outshine entire galaxies. The sheer energy released as matter spirals into such a monstrous black hole is so profound, so brilliant, that it can outshine the billions upon billions of stars in the surrounding galaxy. The blandly named quasar, J0313-16, was and still is intensely active, not just a static light source. It was, at that time, a furiously energetic beacon, spewing out super-hot gases at an incredible 1/5 the speed of light. Imagine the force, the raw cosmic power unleashed from that single point. And this activity wasn't just confined to the black hole itself. It was fundamentally altering its environment. Astronomers, by studying the faint glow around this distant beacon, have detected intense star formation in its host galaxy. This active quasar, this colossal engine, was essentially stirring the cosmic pot, triggering new generations of stars to burst into being around it, even as it consumed matter at a furious rate. Now, here's where J0313-16 truly baffles us and challenges our conventional wisdom. How did a black hole of 1.6 billion solar masses come into being so quickly in such a young universe? Traditionally, we understand supermassive black holes to grow over vast spans of cosmic time. They start small, perhaps from the collapse of a massive star, then slowly accrete matter, merging with other black holes, building up their mass over billions of years. But J0313 simply didn't have that kind of time. The universe was too young, it was too massive, too early to have been fed solely by the deaths of ordinary stars, or even by the slow, gradual collapse of countless star clusters. There just weren't enough stars formed quickly enough to provide the necessary cosmic fuel. This leads us to a truly mind-bending alternative, a scenario that skips these conventional middlemen. What if, instead, this colossal black hole didn't need to start small and grow? What if, instead, it began life already massive? The leaving theory suggests it formed directly from gargantuan blobs of cold hydrogen gas. Imagine vast clouds of pristine primordial gas existing in the very early universe, collapsing directly under their own gravity, bypassing the intermediate step of forming stars. If this hypothesis holds true, then even its birth was spectacular. Such a direct collapse wouldn't have created a tiny seed black hole. It would have been born gnarly, as astronomers might say, a baby black hole with an initial mass of at least 10,000 times that of our Sun. 10,000 stars worth of mass, right out of the cosmic date, ready to begin its rapid ascent to 1.6 billion solar masses. This changes everything. It suggests that the universe had a fast track for creating super heavyweights in its early days, a path we're only just beginning to comprehend. It pushes the boundaries of our models of black hole growth and star formation, forcing us to re-evaluate the initial conditions of the cosmos. And that, I think, is the true marvel of J0313. It's not just a distant dot of light, it's a living question mark, an ancient behemoth that whispers secrets from the cosmic dawn. It tells us that the early universe was a place of extremes, capable of forging objects so immense so rapidly that they defy our very expectations. It reminds us that even when we think we understand a process, like the birth and growth of black holes, the universe invariably throws us a curveball, revealing a deeper, more complex reality. There's a quiet beauty in this pursuit, isn't there? In tracing the path of light that began its journey almost at the very instant of creation, and in asking profound questions about how existence itself began to organize into the structures we see today. J0313 is not just an object, it's a portal, a window into a time of furious cosmic genesis. So, the quasar, unexcitingly known as J0313-16, stands as a monumental figure in the tapestry of the early universe. It's a testament to the staggering power of gravity and the incredibly fertile conditions of the cosmos just after the Big Bang. It's a gentle reminder that the universe, even in its youth, was capable of truly awe-inspiring feats, creating objects that continue to challenge and expand our understanding of everything. It truly is an ancient behemoth, a beacon of light from a time that defies our conventional notions of cosmic evolution. What do you think about this incredible object? Does it spark a sense of wonder in you, or perhaps a feeling of being utterly dwarfed by the cosmos? I'd love to hear your thoughts in the comments below. If you found this journey into the cosmic past as fascinating as I did, consider subscribing for more stories from the vast and mysterious universe. Until next time, keep looking up.